speak slowly because I'm speaking my native tongue, and I know that you're all speaking German. I'll just share my screen. Can you now see my screen, David? Yes, okay. So I'd like you to turn your minds back to the Sydney Olympics. Yes, it's the year 2000 and it's BC. That's before COVID, as we all know. The world was a very different place than the world we find ourselves in now. So I began my long association with trampolines back in 2000. It was after the death on a backyard trampoline in Queensland, New South Wales, in Queensland, Australia. And at this point in time, Australia didn't have any standards on trampolines. Now, when there's a death in Australia, we have a coronial inquest. I'm imagining you have similar things in Germany and in Austria. I watch Rex and Commissar Rex, and Austria has a good system. So the coroner recommended that Standards Australia write a technical standard for the minimum safety for the manufacture and the sale of trampolines in Australia. And I was invited to be chair, which in European language is what you call a convener of this committee. And we published this standard about 2.5 years later. We published it in 2003. From the get-go, Standards, or Australian Standards Trampoline Committee was split into two camps. We had those that thought that the trampoline should be banned, and those that thought that trampolines were an excellent source of exercise and enjoyment and fun for children and even for older people, adolescents and gymnasts. Standards development in Australia is a little bit different to what you're used to in Europe or even at ISO level. We work on a consensus process where everybody's views are respected and compromises need to be made and agreements reached. So it's not that dissimilar to SEN, but it is different. Now, to publish a standard means that I've basically got to get everybody on the committee to agree, which is not an easy task. So this slide here is from an American paper. It's USA Today, and it was published on the 14th of July 2011. So we've skipped about 11 years. And what this article said was there were 50 trampoline parks in the US at that point in time. And the revenue per annum was $100 million US, so quite a lot. And like the committee that I chaired in Australia, the US was also divided. You had the paediatricians in the injury prevention end of the spectrum, didn't want trampolines, they didn't want domestic trampolines, and they didn't want these trampoline parks. And then you had the owner-operators of the trampoline parks, which had a bit of skin in the game, and they definitely wanted them. So I'm just going to quote a couple of sentences from the article. So this was Mr. David Mant, and he was from the International Association of Amusement Parks and Attractions, and he said the trampolines weren't on their radar. This is in 2011, and certainly they weren't on the radar of the American Society of Orthopedic Surgeons, which saw correlated with the introduction of trampoline parks a spike in broken ankles, which is not surprising. I'll show you some data in a few minutes. Broken arms, legs, and non-lethal, so at that stage we didn't have any deaths, broken necks. So Dr. Jennifer Weiss, from the who's an orthopedic surgeon at the Children's Hospital in Los Angeles, said, we do not recommend recreational trampolines. So on the 1st of April in 2013, ASTM, which used to be the American Society for Materials, or Testing of Materials, approved the publication of the very first standard in the world on trampoline parks. So it was for the design, manufacture, installation, operation, maintenance, inspection, and modification of trampoline courts. So it was published in June 2013, and it was basically written by the trampoline park industry in the US. The standards committee, and I was on the standards committee from day one. In fact, I was already on the ASTM amusement rides committee from 2000. They formed a subcommittee called F26, which was special rides and attractions. It's been renamed since to F2461, which I'm also a member of. Speeding along a little bit to the 12th of June 2014, where Australia published its first code of practice. So in June 2013, I was approached by the 4 directors of a company called Bounce Inc. Australia, who were concerned about the number of trampoline parks opening in Australia, where the owner-operators had basically no idea about the minimum safety requirements to build, to operate trampoline parks. And they were concerned that we'd have a death and it would basically kill the industry. So they weren't really worried about killing a person. They were worried about killing their revenue stream. Now, I told these 4 directors that Standards Australia would take several years to publish a standard, and I recommended they form an industry body, which they did. They formed the Australian Trampoline Park Association, and they published a code of practice, which is the document you see before you. The code of practice was an abridged version of the ASTM, which included a whole bunch of material from the domestic trampoline standard, which I chaired, and also some material from the amusement rides and devices standard, which I'm also on. I don't chair that committee, but I represent Engineers Australia on that committee, and I assisted them with the writing of that document. Moving forward to 2018, in fact, the 22nd of October in 2018. So in parallel with all these activities, Standards Australia wrote a trampoline park standard for ourselves. Now, I put in 2 applications back starting in 2013, and the first one got rejected, and the second one I put in a couple of years later got rejected. Surprise, surprise. I was too early. We didn't have any any deaths and our paediatricians weren't screaming from the rooftops. But when they saw the spike, just as we saw in America in the broken legs and ankles and spinal injuries, they raised a project with Standards Australia, and Standards Australia initially they had a forum, a public forum, and at that public forum I was asked to chair the committee that was formed that wrote the standard that you see before you. We split it into two parts, different parts to what we're now doing with the SEN ISO document. We split it into the general safety requirements and test methods, and then the part that we haven't published and it needs to be evidence-based is dismount pits. And we needed to raise money to do testing, and we've had difficulty doing it. So I'm self-funding it out of some spare coins that I had in my pocket from other research projects. So what I'd like to do now is show you a video that we made to show the testing that we were doing for the European Standards Committee to see if they would fund some testing. So what we learned from all those tests was a number of things, but to cut a long story short, what we learned was there's no safe height that you can jump into a foam pit of basically infinite depth and not do a spinal injury. So it's a bit of a dilemma for us with standards writing, because we've got foam pits that are used in gymnastics, we've got foam pits that are used in trampoline parks, and we've got foam pits that they use for, you know, BMX bikes and all sorts of things like that. When someone dismounts into a foam pit at the correct angle, like a trained athlete, there's no problems. I mean, maybe 1 in 10,000 times they get it wrong, and we get a permanent spinal injury. But in trampoline parks, the frequency rate of incorrect mounts into the pits is significantly higher than that. What I would like to do now is show you I just need to get this up to about 4. There. And there's a large gentleman with a white t-shirt on who will be standing somewhere here. And what I want you to do is watch him entering the pit. And he enters, he dives in head first, and he snaps his neck. Now, he did this 3 times in a row, and I'm not going to show you the first 2, but the third one, which was the one where he broke his neck, is what I want you to witness. And he's doing this in the full eyes of the court, the trampoline supervisor. So let me just see if I can get this working. So this fellow in the white is the one we're needing to watch. So here he goes, up and down. And you saw how he dived in head first. So this is about half an hour later. So you can see here we've got the fire and rescue people. They've pulled all the foam cubes out of the way. They've got one of those special spinal stretchers, and they're just about to take him off to the hospital. Now, I was called in as an expert on this matter. He didn't he's in a wheelchair for the rest of his life, basically. So it's a really tragic situation. So the rest of the presentation will be on more happy things, but I wanted to do this reality check with you because there has been 6 deaths in the world through trampoline parks. So what I've got now is some acceleration data that we measured a competent trampolinist in a trampoline park on what we call a high performance trampoline. I'm not sure if you know the various types of trampolines that they have, but there's two plots here. We've got along the x-axis, we've got time in seconds, and we've got g-forces in the y-axis or the vertical axis. And you can see he's pulling about over 9 Gs. So his weight is 9 times what it is if he's just standing still. So every time he hits the mat, he's got 9 G on his ankles, on his legs. And down here we've got 0 Gs, and 0 Gs is weightlessness. So we're in the air. So it's a little bit counterintuitive. The spikes are actually where we've got our feet on the mat, where every force is an equal and opposite reaction. So that's on the mat. And down here we've got the 0 Gs, where we're in the air. And if he's waving his arms around and doing funny things, you get a few forces through the accelerometer. On the bottom graph, we've got a controlled slowing down. So he's jumping, and then he's controlling his activity as he moves to the next one. What I've got here is I did some work with Emeritus Professor Anne-Marie Pendle, and she's from Lund in Europe, Lund University. It's one of the top universities in the world. And we wrote a paper where you could predict the forces that a trampolinist would get. And this is the green pole line trace here. And these dots are actual G-forces that we measured. The next slide is again G-forces. So we've got 5 jumps in a row on a trampoline, and we're pulling 8 Gs. So the blue trace is the trampoline, and what I've got in the red is the jerk, and the jerk is the third differential with respect to time you've got displacement, velocity, acceleration, and then you've got jerk as the third differential. And jerk is a really good indicator, like its name suggests, of things, being jerked. Does that word mean anything to you in German? Yes, okay, good. And the next one after that's called snap. And guess what happens when we have snap? Bones snap. So the fourth differential with respect to time is snap. And what you see here is where the rate of change of the acceleration is the greatest. We get a spike or a maximum in the jerk, and we also see it down here, and again so on and so forth. And if I gave you the next one, you'd see the snap. And these are good indicators of injuries, and I use them in a lot of the research I do. So here's the pyramid of risk. You would have seen this, and this is a work health and safety one, but the same principle applies for sports, where and the numbers will be different depending on what the sport is. Some sports are a lot safer than other sports, but basically, as you go down in the severity, you get more. The frequency rate goes up. So at the moment, we've got 6 deaths in trampoline parks around the world, and there's been a lot of discussion, as Klaus will probably tell you, in the SEN Working Group 17, which is the committee writing the European trampoline park standard, about near misses, and the people from Sweden are very keen on us having something in the standard about near misses. I don't know what your feelings are. I think it's a bit onerous to ask trampoline park owners to do it, but you do learn a lot of information from near misses. So I know where they're coming from. I just don't think it's going to work for that standard. But we'll see how it all shakes down. So just a few facts before I hand it over to question time. So trampolining has many health benefits. With obesity increasing around the world, trampolining provides the populations with an easily accessible form of intense cardio exercise. And you probably know this, but I'll repeat it anyway. But apart from the cardio benefits, trampoline improves our balance, our coordination. It's stimulating the inner ear, the cochlea, all our balance mechanisms that particularly children need to activate at certain milestones in their development. So they're really good for that. They so they improve the balance and coordination. Now they strengthen the bones and the musculoskeletal structure. People think, well, bones are bones. Bones need to be exercised just like muscles. The tendons, like the attachment points, they all need to be strengthened. And the best way to do them is to stress them, but to stress them at a level that the body can handle. And when you stress them, you make them stronger, and then they can handle more activity. So if you're from Germany and Austria, I know skiing is really a very popular sport there. And if you ski and expose your body to high loads, stress when you're young, then you will be stronger, have stronger bones, tendons, muscles, etc. And trampolines do this as well. So we cycle the load, and on a domestic trampoline and the standard ones in trampoline parks, we cycle it up to about 6 Gs is what we normally get. And one of the other benefits you get, we've got 2 circulatory systems in the body. We've got the blood and the veins, which you're all familiar with, and we've also got the lymphatic system. And the lymphatic system gets activated by trampolining because we're cycling from 0 Gs to 6 Gs, and the muscles are pumping the toxins out of the body. So there's all sorts of really great benefits from trampolining, and NASA's done research with trampolines or bouncers. So trampoline parks are taking over in large numbers in Europe and all around the world, and they're providing our children with this vital exercise. They're very appealing to children. They have lots of fun. They're also appealing to big kids like myself, who like to exercise, and it motivates our kids to exercise. So they can make a significant contribution towards reducing inactivity and all the distractions of electronic equipment that our children are continually exposed to. So I don't want people to shut these places down, even though they can be potentially quite dangerous. So they increase our motor skills, our balance, our coordination, our bouncing ability, our endurance, all sorts of great things. And I suppose at this point in time, I would like to maybe hand over to Klaus and question time if we've got some time, Klaus.
Okay, I take over if you...
Oh, David, sorry.
Klaus is okay with that. So first of all, we all give you a hand, David. Thank you very much. Thank you. Klaus is already applauding. There are a few questions for you. One is from me, actually, but before me, there was Florian from Austria who had a question.
Yeah, I will share the slides if you want with the question, or...
Yes.
Okay, just a second, please.
So do I have to give it back to you?
Right now, you can prepare for answering the tough questions.
Okay. now I'm scared.
So, you see the question. First of all, it was Florian.
What do I think about restrictions for younger children? Did you test special crash dummies for kids? No, we used an adult test dummy. We used the Thor dummy that we use for other testing. These dummies cost in Australian dollars over 250,000. So we really can only afford one dummy. But the results and the neck injuries would, I mean, the fact that it failed at millimeters fall, it would do the same with the child. Restrictions with children, it's a question that I'm asked all the time, and it's one that's been put to the WG7, the SEN committee, and we had to address it at a local level as well. Cyclically loading young children, and we ruled a line in the sand at 6 years, just as the paediatricians in the US did, that we banned the usage of trampolines in the backyard for children under 7. And the trouble with that is we can't control it. It's children in their own backyard with this device that's really a toy. It's really a playpen. I mean, some parents, now that we've got the circular trampoline with a net that they can zip up, they put their children in there, and they might put 2 or 3 children in there together, and they could jump around. And you can get another thing happening where you get what's called a double bounce, where you get a modal point on the trampoline. And this is particularly bad for us as parents if we go in with our children who are much lighter weight and we jump with them and we transfer all our momentum into the child. We can snap their back in an instant if they are at the wrong place at the wrong time. So it's not just the cyclical loading of the bones, it's also things like double bounces. Now in trampoline parks, the children don't go in for, like in a backyard, they can be there for the whole day. Like literally, at least in Australia, when the weather's good, they could be playing and bouncing for hours. And we're told by the paediatricians that this cyclically loading during young age is a bad thing. Within trampoline parks, where their exposure is limited to, say, half an hour at a time, maybe only once every couple of weeks, the evidence is that this doesn't cause long-term damage. So and finish the question there.
Yeah, and the second question was, do you see it?
So what do I think about? No,
Yeah,
that's
that was the second. Did you also do research on airbags? And this becomes more popular in Austria, also in trampoline parks and also in other fields such as bike parks or snow parks.
We've done some testing on them. It's not very rigorous testing. Airbags in Australia aren't as popular as in Europe. But what we did learn, and it's more anecdotal evidence rather than based on numbers and figures, is that the pattern of behavior is different with an airbag. So the way people dismount onto an airbag is different to what they do in a foam pit. And that accident that I showed you earlier, the video, excuse me, you wouldn't see that behavior on an airbag. No one would dive headfirst onto an airbag. So we don't see those types of injuries being presented in the emergency departments, because people see a surface, and when they see a surface such as an airbag surface, they behave very, very differently.